Module 14, Kinetics. Factors that affect the kinetics of a chemical reaction. Experiment 14.1.
This experiment is going to help you to see the effect of different parameters on the rate of a reaction. So we're going to run a chemical reaction under 4 different conditions and see how those conditions affect reaction rate. One will be concentration and temperature as well. So the first thing I'm going to do is I want to heat up some water. I need to fill up a beaker with some tap water. And this is to create a condition of hot temperature. So I want to get this alcohol burner going and get that beaker heating up. And while that's heating, I'm going to prepare my 4 test tubes for the 4 different conditions of the chemical reaction. So the first thing I'm going to do is I'm going to take 3 test tubes and fill them halfway with toilet bowl cleaner. Now, but to do this, this is pretty caustic stuff. So I recommend that you wear gloves for this lab, at least for the pouring of the toilet bowl cleaner, because again, if you get this on your hands, it could cause some burns. If you were to get some on your hands, go just rinse them off right away. But because this is potentially caustic, we want to take precautions. So we want to fill these up halfway, or halfway with toilet bowl cleaner, 3 of them. And I'm doing this over a tray. Again, this is so that if I accidentally spill some, it's not getting on the table. It's kind of bubbly. So indeed, I am spilling some, which is why it's good to have a tray or some kind of protective surface for your labs. Okay. This stuff is also pretty slippery. So again, be intentional, careful, and slow as you do it. All right, kind of bubbly. I'm going to use a paper towel and just kind of get the fluid off. The 4th test tube, we're only going to add about an 1/8 full of our toilet bowl cleaner and then dilute that with water. So I only want this about 1/8 filled. And when I say about, I mean about. It doesn't have to be exact, but we do want it less than the others. Okay, that's all I need from this toilet bowl cleaner. So I'm going to set this over to the side. And now we want to dilute this with water so that it's about the same level as the other 3. There we go. Okay, they're not exact, but they're close enough for the purposes of our lab. And so these are the 4 test tubes beginning to set up the conditions. All right, now I want to stir that diluted one up a little bit to make sure it's nice and mixed. Okay. Okay, now we're going to take an antacid tablet. I'm going to take these gloves off so I have better dexterity. Set this aside. And I just have a regular antacid tablet, and I'm going to cut it into 4 pieces. You may not be able to see me doing this, but I'll lift them up to show you. Just have a sharp knife, and I'm bearing down, cut it in half, and I'll cut each half in half again. Okay, so I have 4 pieces, and I'll hold them up so you can see. 4 pieces of antacid tablet. All right, now, the next thing I'm going to do is I want to take one of those pieces and I want to grind it into a fine powder. So one of the 4 pieces, I'm going to set it in a spoon. You can use 2 spoons to do this, one inside the other. I'm using a measuring spoon and a regular spoon. And I'm just smushing them together to get a fine powder. So you can see one of my 4 pieces of antacid tablet is powdered. Okay, my water in the beaker is now boiling, so I'm going to go ahead and cap off my burner. And I'm going to set this beaker down over here. It's very hot, so be careful doing that. Okay, so now it's time to, we're almost done setting up our conditions. Okay, we're going to take one of the beakers and put it in hot water, not the diluted one, but one of the non-diluted ones. And this would be, one of the test tubes. This is test tube number 3 that's going into the hot water. Okay, now we want the toilet bowl cleaner in that to get hot. So we'll see how this chemical reaction occurs under warm conditions or hot conditions. And then we're going to put a test tube, or a regular antacid tablet, into test tubes 1, 3, and 4. So you need to number your test tubes unless you can remember which ones they are. If you keep your beakers, if you're keeping your test tubes in a beaker, like the lab is suggesting, then you will need to make sure you're using a pencil or some tape and a pencil to number them so you know which ones are under which conditions. That's ideal. Because I have mine in a test tube rack, I'm doing this so you can see all of them simultaneously. It makes it easier for you to see. So I'm not going to have to number mine because I'm going to know which ones they are. So 1, 3, and 4 are going to get regular or whole antacid tablets. This one's test tube 3, and this is 1, and this is 4 right here. Test tube 2, I'm going to put the powdered. Very carefully add that in. And in a second, I will kind of move them around so you'll know which ones we're doing here. And I'm going to use a different stirring rod to kind of get that mixed in. Okay, so what you're seeing right now is reactions occurring. You can see the one in the heated temperature reacting very rapidly, producing tons and tons of bubbles. The one that has the diluted toilet bowl cleaner is reacting a little bit, and the one with regular toilet bowl cleaner and just a regular chunk of antacid tablet is moderately reacting. And then the one with the powdered toilet bowl cleaner is actually kind of going to town and reacting very well too. Now you want to continue to stir these a little bit at a time just to make sure that everything is mixing well. And you can see we have some really good mixing here. And notice make note in your lab notebook how active each of the 4 test tubes is reacting. And again, note the conditions under which those reactions are occurring. Now I'm going to explain what's happening with all of this right now.
Let's go over what happened in the experiment. You had 4 test tubes with a reaction going on inside them. Test tubes 1 through 3 were filled halfway with toilet bowl cleaner. Test tube 4 was only 1/8 full, and the rest was water. Test tube 2 had powdered antacid, while the other 3 had an antacid chunk. And test tube 3 was placed in a beaker of hot water, so that reaction was run in a warmer environment. Therefore, we ran this reaction under 4 different conditions. Now, after you ran the reaction, test tube 1 should have only a little bit of antacid tablet left in it, but all the powdered antacid should be gone from test tube 2. All of the antacid chunk should be gone from test tube 3. Test tube 4 should still have antacid left, and a lot of it. Now let's discuss why. First, take a look at the chemical reaction that was occurring in the test tubes. Hydrochloric acid from the toilet bowl cleaner reacted with calcium carbonate from the antacid tablet and produced water, calcium chloride, and carbon dioxide gas. The bubbles coming out of the solution in the test tubes were the carbon dioxide gas. The amount of antacid left over in the test tubes after a certain time helps us to learn something about the rate of the chemical reaction. After 5 minutes, the reaction in test tube 4 had not gone quickly. There was still lots of reactant, the antacid, left. But in test tubes 2 and 3, there was little or no antacid left at the 5-minute mark, so the reaction proceeded quickly in them. And in test tube 1, there still was antacid present, so the reaction in it proceeded slowly, but not as slowly as in test tube 4, because there was not as much antacid tablet left over than what was in test tube 4. So this experiment helped us to see the relative rates of the chemical reactions under different conditions, and we can make some conclusions from that. Looking at test tube 1 and test tube 3, the only difference between them was temperature. Test tube 3 was hotter, and it had a faster reaction rate. So this tells us that chemical reactions have a faster rate at higher temperatures. That should make sense because higher temperatures make molecules move around faster, enabling them to more readily come in contact with each other. Now look at test tubes 1 and 4. The difference between these two is that test tube 4 had a lower concentration of toilet bowl cleaner. Test tube 1 had a faster reaction rate than 4, so we can say that dilute reactants lead to lower reaction rates. And again, that should make sense because there's a less chance of reactants finding each other to react. Finally, look at test tubes 1 and 2. The difference between them is that test tube 2 had powdered antacid. It also had a higher reaction rate than test tube 1. So we can conclude that powdered solids react more quickly than non-powdered solids. Notice how we compared test tubes 2, 3, and 4 to test tube 1. That's because the reaction that occurred in test tube 1 happened under normal conditions. It had a regular concentration of toilet bowl cleaner, was at room temperature, and had an uncrushed antacid tablet. Each of the other test tubes had one of those parameters changed. So we call this a controlled experiment. This is where one test is done under normal conditions and the other tests are compared to those conditions. The test under normal conditions is called the control. The other tests are done with one aspect changed. That way we can compare how changing that one aspect affects a reaction. Let's discuss more about why these changes affected our reaction rate. First, remember that valence electrons in an atom are the electrons responsible for the atom's chemical behavior. Molecules are formed when valence electrons are transferred or shared. If they're transferred, ionic molecules are formed. If they're shared, covalent molecules are formed. So in order for a chemical reaction to occur, reactants need to get close together so their electrons can either be transferred or donated. We can say then that to react, chemicals must collide with one another so that their electrons can be either transferred or rearranged. That's the major idea we need to know when we look at factors that affect the rate of a chemical reaction. So think back to test tubes 1 and 3. 3 was run in a hotter temperature. When temperature increases, the rate of a chemical reaction increases. And again, the higher the temperature, the faster the reactants will be moving, thus making it more likely that a collision will occur. That's because the kinetic theory of matter says that when a temperature increases, the motion of the molecules or atoms in the substance increases. So we can say that higher temperature increases chemical reaction rate because the reactant molecules or atoms move faster, increasing the chance for a collision. Now think back again to test tubes 1 and 4. Test tube 4 had less of a concentration of toilet bowl cleaner and thus had a slower reaction rate. As concentration of a reactant decreases then, chemical reaction rates decrease too. Again, this has to do with collisions between reactant molecules. If there is a smaller concentration, there are not as many reactant molecules present to collide. So we can say that decreasing concentration decreases the chemical reaction rate because there are fewer reactant molecules or atoms to collide with one another. Finally, look again at test tubes 1 and 2. Test tube 2 had the crushed antacid tablet, which increased the rate of its reaction. When the tablet is crushed, this spreads out the molecules over a larger area within the test tube. It increases the surface area of the reactant, and that makes it more accessible to the other reactant, increasing possible collisions. In a solid chunk, there are fewer opportunities for the antacid reactant to come in contact with the toilet bowl cleaner reactant. So we can say increasing the surface area of a reactant increases the reaction rate because the molecules or atoms of the reactant can more easily mingle with the molecules or atoms of the other reactants. These statements in the official plaque here summarize what we just learned. All of this discussion should help you understand that the major factors that affect the rate of a chemical reaction can be understood by looking at the collisions that have to happen between the reactants of a chemical reaction. Understanding the effects of temperature, concentration, and surface area then will be helpful in chemistry.